Welcome back everyone. Session 5, Page Object Model and Fixtures. Everything we've built so far has been correct, but if you look at it honestly, it's still just a collection of individual scripts. Today is where that changes. We're going to structure an actual scalable framework, page object classes that centralize your locators and actions, Playwright's custom fixtures to wire those classes into your tests automatically, and shared login state so you're not logging in through the UI on every single test. This is genuinely one of the most important sessions in the whole series because it's the difference between a pile of scripts and a framework your whole team can actually build on. Quick recap of session 4. File upload and download, iframes, pop-ups and new tabs, native dialogues, drag and drop, and dynamic content. Today's agenda, 6 things, why and how to build page object model classes. Playwright's custom fixtures through test.extend. Combining POM classes with fixtures together. Fixture scoping, test level versus worker level. Shared login state through storageState. And environment and config management. Let's start with the problem. This actually solves, because I want you to understand the why before the how. Without any structure, every single test redeclares the exact same locators over and over. And that means a UI change requires fixing dozens of tests individually, instead of fixing one class in one place. 3 concrete benefits fall out of solving that. Reusability. The locators and actions for a given page live in exactly one place and get reused across as many tests as need them. Maintainability. A UI change means updating one class, not hunting down and updating every single test that happens to touch that page. And readability. Tests start reading like actual user stories. LoginPage.signin instead of 5 lines of raw locator soup that you have to mentally pass every time you read it. Let's look at the actual shape of a page object class. 3 pieces. The constructor, which takes a page and defines each locator as a property on the class. Locator properties named fields like this .email input, defined exactly once and then used everywhere throughout the class. And action methods, higher level methods like sign-in, taking an email and a password that compose those locators together with actual actions. Keep this 3-part shape in your head because we're about to build a real one together. Let's build a complete login page class together, line by line. We import page and locator from @playwright/test. We export a class called LoginPage. It has 4 read-only properties: page, email input, password input, and sign-in button. In the constructor, which takes a page, we store that page and then we define each locator. Email input is page dot get by label email. Password input is page dot get by label password. Sign in button is page dot get by role button with the name sign in. Then 2 methods, goto, which just navigates to /login, and sign in, which takes an email and a password, fills the email input, fills the password input, and clicks the sign in button. That's the whole class. Notice, none of the actual test logic lives in here. This class only knows how to interact with the login page. It doesn't know or care what a specific test is trying to verify. Now, let's actually use that class inside a real test. We import login page from our pages folder. Inside the test, const login page equals new login page, passing in page. Await login page.goto, await login page.signin with an email and a password. And then we assert that a welcome back message is visible. Compare this to the raw locator version we wrote back in session 2. The test now genuinely reads as a story of user intent. Go to the login page, sign in, expect to see a welcome message with all of the implementation detail tucked safely away inside the class, out of the way. A handful of best practices worth internalizing right from the start before bad habits creep in. Keep assertions out of page objects. Return locators or values from the class and do your actual asserting in the test itself. That keeps the class reusable across many different tests with different expectations. One class per logical page or major component. Don't try to model every single div on the page. That's over engineering in the other direction. Name methods after user intent, not implementation. Sign in, add to cart, not click button 3, which tells you nothing about what it's actually for. And compose larger flows from smaller page object methods rather than duplicating the same steps across multiple places in your codebase. Now let's talk about fixtures. You've been using the built-in page fixture since session 1. Test.extend is how you define your own, including ones that hand back ready-made page object instances. Here's the code. Import test as base from at playwright/test. Import login page. Then export const test equals base.extend with a type of login page : login page, and inside it an async function that takes page and a use callback. It calls await use, new login page. That use function is the key piece here. It's what actually hands the fixture's value over to your test. Any code you write after that, useCall runs afterward as teardown, once the test has fully finished. Let's see what using this actually looks like in a real test file. Import tests from our own fixtures file instead of directly from Playwright. Then test, user can login, async, and now the test receives login page and page directly as parameters. Await login page.goto, await login page.signin, assert. Welcome back is visible. Notice what's gone. No more new login page appearing in every single test file. The fixture constructs that instance for you automatically, and TypeScript infers the correct type without you having to do anything extra. This scales up cleanly to as many page objects as your application actually needs. Define a pages type with login page and dashboard page. Extend base with both of them, each one following that exact same use pattern. And then in any given test, you just ask for whichever ones you actually need. For example, async, login page, dashboard page. Here's what's genuinely elegant about this. Every page object your suite needs becomes a fixture, and it only gets constructed and injected when a specific test actually asks for it. Playwright resolves and caches these lazily on a per test basis, so you're not paying any setup costs for page objects a given test doesn't even use. Let's talk about how long a fixture actually lives, because there are two different options here, and choosing the right one matters. Test level, which is the default. A completely fresh instance gets created for every single test. This is the safest default because there's no state leaking between tests, and it's genuinely the right choice for page object instances and page state specifically. Worker level created exactly once per worker process and then reused across every test that worker runs. You opt into this with scope : worker in the fixture definition. This is a good fit specifically for expensive read-only setup, something you genuinely don't want to redo for every single test. Let's see a worker scoped fixture in actual code. Export const test equals base.extend with an API token fixture defined as an array. First element is the async function, which fetches a service account token, described here as expensive and read-only, and then calls use with that token. Second element in the array is the options object, scope : worker. One important warning here: worker scoped fixtures are shared across every test running in that worker. Never store per test mutable state inside one of these. because you will end up with tests silently interfering with each other in ways that are genuinely painful to debug. Let's move to a related but distinct problem. Logging in through the UI in every single test is slow and it's repetitive. Playwright can save authenticated state exactly once and reuse it everywhere. Here's the flow, 4 steps. Log in once in a dedicated setup project. Save cookies and local storage out to a file. Tests then load that file as their starting state, and every test after that starts already authenticated with 0 login steps of its own. This is literally what session 3's before each login step was doing manually every single time it ran. storageState removes that repeated cost completely for the entire suite. Let's look at how you actually implement this, starting with the setup file itself. We create a file called auth.setup.ts, import test as setup from at playwright/test dot, then colon setup, comma, quote authenticate, quote comma, async comma, page dash, navigate to /login comma, fill in the email comma, fill in the password comma, click sign in dot, and then the key line, await page dot context dot storage state with a path of auth/user.json. This runs exactly once as a dedicated setup project before the rest of your suite even starts running. Now let's wire that setup file into the actual config so it runs automatically. In your projects array, first a project named setup matching against auth.setup.ts. Second, your regular Chromium project, but now with storage state pointing at auth/user.json inside its use block, and critically, dependencies array containing setup. The dependencies array is what guarantees the auth setup runs first every single time before this project's actual tests start executing. Let's zoom out to environment management more broadly, running the same test suite against different targets. .env files store per environment secrets and URLs like base URL and a PI key outside of source control entirely. Process.env inside your config, read those environment variables inside playwright.config.ts to set your base URL dynamically. And multiple projects, define separate projects like staging and production, each one pointing at a different environment. Let's see this in practice. In your config, base URL equals process.env.base_URL or a fallback of http://localhost:3000 for local development. Then from the command line, base_URL equals the staging URL, npx playwright test targets staging, and base_URL equals your production URL targets production. Though I'd add a real caution here, only ever run smoke tests against production, never your full destructive regression suite. Let's cover today's anti-patterns. Assertions inside page objects. This couples the class to specific expectations, and it works against the entire point of building a reusable class in the first place. One giant God object, a single class, trying to cover your entire application becomes just as unmaintainable as having no structure at all. That's not actually a win. Committing auth/user.json storage state files contain live session data. Make sure this is in your Gitignore, always, and mutable state inside worker fixtures, shared across every test in that worker, and a real source of cross-test interference if you're not careful about it. Your turn. 5 things. 1. Convert session 2's login test into a LoginPage class with goto and sign-in methods. 2. Create a custom fixture that hands your tests a ready-to-use login page automatically. 3. Add a second page object, something like dashboard page, and combine both of them as fixtures together. 4. Write an auth.setup.ts that saves storage state and wire it into your playwright.config.ts. 5. Confirm that a test using storage state actually starts already logged in with no UI login step needed at all. Let's recap. 4 things. POM classes centralize locators and actions, so tests read as genuine user stories instead of raw implementation detail. Test.extend turns page objects and honestly anything else you need into injectable fixtures. Default to test level scope always and reach for worker level scope only for expensive read-only setup. And storage state combined with a dedicated setup project skips repeated UI logins across your entire suite. Next time, session 6, API testing and network control. We'll use Playwright as a proper API testing tool, combine API setup with UI verification, and mock network responses directly inside UI tests. That's where Playwright stops being just a browser tool and starts being a full end-to-end testing toolkit. Any questions, please post in comments section.